Hi, everyone. Welcome to UJUG. We are going to get started in just a moment here. On screen with me is Dave Smith, our presenter, and James Judd from Lucid Software, who'll be doing our sponsor section today. Lucid is the physical host of the meetup, but not right now. James is not at Lucid at the moment. He is in his pseudo loft. Is that how you describe it, James? So James, describe what is behind you, what people see behind you in these shutters.
So that's not an exterior window. That is an interior window, and that is the dining room down below there. So I can go out there and throw paper airplanes at people, or rocks, I guess, if I don't like them. Who knows?
Okay. Mysteries of the different rooms. So when was that structure built? Like, that's not a usual thing.
No, it was built in the 80s, and it was built by a general contractor who was great at building things but not good at designing things.
Well, that's good that you won't have as many maintenance problems. All right, let me share my screen and show my intro slide here for our logo here. All right, so everyone should see our fancy UJUG logo, and we will go right to, let's see. So here is Lucid's logo, and we'll go right to James here, who, like I said, is one of our UJUG sponsors, and he will tell everyone a little bit about Lucid.
Hi, everybody. So thanks for having me. My name's James Judd. I'm an engineering director at Lucid Software. Been with the company for 6.5 years, and I work with all of our internal engineering teams. So I get to work with site reliability engineering, performance, tech debt, a lot of these teams that operate behind the scenes to keep things running smoothly. So let's talk a little bit about Lucid. We've been around for 10 years, around 800 people, growing like a weed and doing really well, and would love to have you, software engineers and other technologists, come work with us. And I guess what I'll do here is, rather than kind of go through the typical pitch of here's our tech stack and various things like that, I'll talk a little bit about Lucid Spark, which is the product that we launched most recently and how it came into being, and kind of paint a vignette of Lucid and see if this is a place that you may be interested in. So last spring, we identified a market opportunity for Lucid Spark, which, for those of you who are unfamiliar, is a whiteboarding application. You can drag out notes, you can brainstorm, you can plan things for Jira, various things like this. But it started off as just as a whiteboarding application. This was an area that was taking off before the pandemic, and after the pandemic, when people weren't able to go to whiteboards anymore, it was taking off very, very quickly. It says, okay, there's some competitors, there's a major opportunity here, and we already built Lucid Chart, which is an online diagramming application. So we think it would be pretty easy for us to pivot into this space with a new product. We identified a small group in May that built out a proof of concept in a couple of weeks using our existing thing, and we said, okay, we're doing it. Q3, we pivoted the entire engineering org, just on a dime, and said, we're getting this thing shipped out by October. Because again, timing was crucial. People were picking up whiteboarding solutions. It was the middle of the pandemic, and everybody pitched in. It was awesome. We got collaboration working from only 6 to 12 people. Suddenly it was working with 50 to 100 people. We built out the new application in entirety. We migrated domains and launched a suite of products rather than being on a single domain. So everything from performance to infrastructure to product was cranking on all cylinders. We got the thing launched in October. And of course, the launch was pretty good, a little rocky as they always are, but it launched and it's been doing amazing and is going to be a major part of our revenue for this year and years moving forward. So that's the sort of engineering company we are. We've been around for a long time. We're still pretty big, but we're still scrappy, and we can still, ship products here in just a matter of months and do some really cool stuff. So if that sounds like a place that you'd be interested in working, you can check us out at lucid.co. At our careers page. Feel free to also send me an email. I'm james@lucidchart.com. Love to get in touch. So thanks again for having me, and enjoy the presentation.
Thanks, James. And so on our topic of continuous deployment, I know Lucid does continuous deployment. To help really whet people's appetite on this topic, what do you think was first of all, what's your favorite part of CD? And then what do you think was the most important factor getting to CD?
So at Lucid, we do see some of our services go out every 15 minutes. Most of our application goes out twice per day, once in the morning, once in the afternoon. There's a still small chunk of our application that goes out once a week. And when I joined, everything went out once every 2 weeks. And to kind of answer Don's question, what's my favorite part? Two things. Number one, if I'm an engineer shipping features, I love the fact that I can write something and it can be out in the afternoon. That's fantastic. It makes worrying about backwards compatibility much easier because you're like, okay, I shipped that this afternoon. I can take the next part of it this next morning. It's no longer like I did this month and that next month. As an SRE, and as someone who used to have to wake up in the middle of the night and fix the website, I love continuous deployment, which may seem counterintuitive because the change sets that get shipped to production are so much smaller. If something breaks, I'm looking at 6 hours of changes rather than 2 weeks of changes. Finding a needle in that smaller haystack is so much easier. And the two probably most important things were, number one, you got to have organizational buy-off. We kind of pitched it as we want to have smaller change sets. We want to be able to move more quickly. We want to be able to get high quality software to end users quicker. And everyone was on board with that. Everybody wants that. The second thing is we were moving a little bit. And one day we said, you know what? We just got to do this. It's going to be rough. We'll make it happen. We'll learn things along the way. We can't wait until everything's perfect. We're just going to, here's 6 months. We're going to get there, come hell or high water. And, it was a little rough. And we broke some things and we took down the site a couple times. But in the end, totally was worth it. And I would much rather be where we're at now and very excited to finish out the last few holdouts that aren't continuously deployed. So that's the answer to your question, Don.
Great. That was a very complete answer. And I am, I love this topic and I'm excited to get started. So thanks, James, and thanks Lucid Software for its continued support. And hopefully we can get back into the facility there at Lucid. We don't have any update on that, but you'll know, we'll announce it whenever we figure something out there. So let's see, I will now share my screen and we will get back to my slide deck of intro. Okay, so other sponsors that we have, Goldman Sachs, they're one of our diamond sponsors. Let's see, let's try this way. Tech Systems, another diamond sponsor. JFrog, they give away software a lot through us. Master Control, Overstock, and Applitools. Those are our current sponsors and we thank them greatly. So if you have choices, please choose our sponsors. It's how we can afford all this, the technology here. And then, what we do when we don't have these physical meetings is we donate the money that we would spend on food to the local food bank. And so we've been doing that during the pandemic. So let's go on to upcoming meetings. So next month, June, we have NVIDIA coming, and they're going to talk about their mixed reality solutions and kind of the state of the AR, VR world. And we've been working to get them to present for a while, and we're really excited to finally get them here. And then in July, we've got Mark Richards coming. And if it was like a year and a half ago, Mark did a presentation called The Rise and Fall of Microservices. And it was just a blockbuster presentation, 200 people there. It was just a wonderful talk. And so we're going to do an interview session with him, just like we did with Venkat last month, where we talk about various topics and just touch on a bunch of different things to really pick the brain of an industry leader like him. So it's going to be an exciting meeting. I'm really excited for that. All right, so let's talk about door prizes for this month. You're automatically entered for the door prize just by attending, but you have to be here to win. We'll check in the chat to make sure people are here at the end and that you can use these prizes. Okay, so for the meeting format today, we're trying a new meeting format inspired by the interview session that we had with Venkat last month. So we're going to have a shorter presentation, about 45 minutes to an hour, and then we're going to have an extended interview, a Q&A session. And so what I'd like everyone to do is contribute questions in the Ask a Question dialogue at the bottom of the screen. You'll see there on Crowdcast. What I'd like you to do is click on that, put your questions in there, and then we'll answer those at the end. And then we've also got some general interview questions, some related to continuous deployment, some not. And this is a real fun thing that we're trying to do to kind of add value over just a traditional conference talk. and I'm curious to get people's feedback on what they think about it too. All right, so let's see. And that's it for the slides and all this other prep. We're just going to get right to it. So please, everyone, welcome Dave Smith by typing something friendly in the chat, and I will turn the time over to him.
All right. Hey, everybody. Okay. Let's see. It claims to be sharing my screen. Can you all see my screen?
Yep, I maximized it. You're good to go.
Okay. Okay. Thanks, Don. Thanks for the intro. So happy to see everybody sort of through the pixels. Really, really excited to be here with you all today. The talk I'm going to give is based on the last 5 years of experience I've had working at Amazon and now at eVisit as the head of engineering, getting to continuous deployment. So let's get into it. So first of all, I just want to tell you a little bit about me. Can't resist. Before that, I just want to tell you who I'm not, which is I am not an author. I am not a consultant, and I'm not here to sell you anything. I am the father of 5. I've got 20 years of experience as a software engineer. I am currently the head of engineering at eVisit, which is a telemedicine startup that we are building. The company's already built, but we are running. We are a fun engineering department of about 25 engineers building the next generation of software that doctors use to connect with their patients without forcing the patients to come into the office. We are hiring, by the way. I'm a former Amazon engineer, and I like to ride bicycles. And here's a picture of me riding my bicycle after finishing a 200-mile bike race with my dad in his 60s. You can see in this picture that we have matching socks and matching muffin tops. All right, I want to tell you what I want to talk about today. Here is what the talk is going to feel like as you pay attention, because I'm going to cover a ton of information. But there is a method to this madness. What it is it's set up to be more abstract in the beginning and move towards more concrete in the end. And we'll actually end with screenshots and detailed callouts on the systems that I've worked on. But it's going to feel pretty abstract at the beginning, so bear with me. I'm going to go really fast. I will ask that you please make little notes. You can throw notes in the chat. If you want to ask questions, throw them in there. We'll get to them at the end. Make notes to yourself. If anything is unclear, guaranteed that some parts of what I say are going to be unclear, because I'm going to be moving super fast through this because I've got a lot of material I want to share. And you can rewatch this on the recording later to pick up stuff that may have flown by. Also, I just want to be clear that I am not an expert on all continuous deployment tools. So if you ask me about some tool, I will probably not know the answer. This talk is not at all an inventory of the marketplace for continuous deployment. It is really more about my experience observing hundreds of teams. Literally, that might be surprising, but I worked on the Alexa project at Amazon. There were about 500 engineering teams that worked on Alexa, and I just saw so many of these teams and what they did with continuous deployment. So that's what I'm sharing here today. And I'm going to be talking a lot more about governing principles and less about specific tools. And my purpose is that this will be more of a timeless talk that you can use to make decisions, not to give you a specific recipe to follow with specific tools and technologies. All right, so let's start with the most abstract thing by defining continuous deployment. So continuous deployment is an automated build and deployment tools and processes that allow your team to ship small code changes to production and respond to business needs quickly without introducing bugs. All right, let's break that down. It is automated build and deployment tools and processes, very important, that allow your team to ship small code changes to production and respond to business needs quickly without introducing bugs. This is it. This is the whole thing that continuous deployment delivers. The whole rest of this talk is going to be talking about how we do that. But first, I need to tell you what continuous deployment is not, because I think some people have some misconceptions about it. So I want to tell you what it isn't. The first thing is editing your code directly on your production servers, not continuous deployment. Sending code to production right away, not continuous deployment. Shipping code on some regular schedule where you do the same thing on a schedule. That is not necessarily continuous deployment, although continuous deployment does allow you to do that. But if you're doing that, that doesn't necessarily mean you're doing CD. Also, it is not continuous integration. That is a totally different thing, but Some could say that continuous integration is a subset of continuous deployment, and I will talk about that some more later. So what about this term continuous delivery? You've probably read or seen this book by Jez Humble called Continuous Delivery. It's like 1,000 pages long. I read this book, and I really didn't learn a ton that I felt was applicable from this book, other than maybe governing principles. After spending just 2 weeks at Amazon, I felt like I learned more about how to do continuous deployment than I did after reading the continuous delivery book. But the reality is, these are actually the same thing. Don't let anyone tell you they're different. You can try to split hairs and say they're different, but really continuous deployment and continuous delivery are the same thing with the same goals. And I will use these terms interchangeably. Actually, I will just use the term continuous deployment more so than continuous delivery. What about continuous integration? So this is a totally different thing. Continuous integration is simply where you have a build and test system that runs automatically anytime a developer merges code into your main branch and gives you like a green light, red light situation. Continuous integration does not necessarily have anything to do with production deployment, and that is where all the hard stuff is. So continuous integration is actually pretty easy to do. Continuous deployment is much, much harder. So these are totally different things. Okay, with all that groundwork laid, let's talk about the difference. Actually, I already did this. Let's just skip that. Let's start with tenets. So remember I said we're going to start abstract, and then we're going to go to concrete. So tenets. Tenets are guides that help us to make decisions. I've identified about 10 tenets that can guide a team when you are building continuous deployment. You could also think of these as kind of like requirements. And they are meant to help you choose. So like one of the things that was mentioned in the intro before I started speaking was that one of the advantages of continuous deployment is that you get small change sets. That is a tenet, and I'll talk about that in a minute. Okay, so let's jump into these tenets. Number one, we favor frequent small changes over infrequent big changes. We favor safety over speed to production, meaning if I had to choose between having a quick turnaround time to get code to production or having a safe process for getting code to production, I choose safety. We also favor automation over speed to production. It really doesn't matter, in my opinion, how long it takes your code changes to get to production, as long as they are fully unattended. I have seen successful deployment pipelines that take literally weeks to complete a code change to production. And I'll talk more about that if we have time at the end. We have to remember that our applications that we build and ship are much more than just the code that we as developers write. They are dependency code. They are the underlying operating system. They are network infrastructure. They are databases, and so much more. All of these things need to be considered for a successful continuous deployment strategy. The next tenet is we do not accept downtime during deployments. We don't deploy artifacts built on developer machines. We need a repeatable, consistent place where all artifacts that get deployed are built. We favor decoupled deployment pipelines, meaning that not every piece of your software application has to be on the same deployment pipeline. And the way that we draw those lines is by frequency requirements. For example, some code changes more frequently than other code. The frequency of changes, that first one was meant to be how frequent you need to deploy it. Some code has a longer deployment cycle, some has shorter. Some code changes more frequently than others. The team structures. If you have a team that is responsible for one piece of code and another team that is responsible for another piece of code, it is a really good idea to have them on separated deployment pipelines so they aren't stepping on each other's toes and depending on each other or getting blocked by each other. And we favor incremental adoption over waiting too long to get to a perfect full CD. And I'll talk about incremental adoption toward the end. And lastly, I think this is last, yes, we decouple code deployment from feature releases. And I'll talk a little bit about this at the end too, but the idea of pushing code to production and the idea of making new functionality available to users should be separate. And that's really, really important for CD because most users can't consume changes as frequently as development teams can push them out. All right, and now some vocabulary. We'll be brief here I promise we'll be brief before we get into the meat here. First of all, blast radius. Blast radius is a term that describes how much impact a failure has. The goal of CD is to find failures while they have a small blast radius, ideally before any users are affected by them. But a big blast radius change would be an example of the whole app going down or a bug that affects every single user. A small blast radius change would be a bug that only affects 1% of users for a small period of time. The idea of a rollback is when your deployment system automatically restores the previous version of code. A stage, you'll hear me use the term stage. A stage is nothing more than a step in your deployment process. Every deployment process has multiple steps, and we call these, or I'm going to call these stages in this talk. And lastly, integration tests. So I'm going to use the term integration test to cover what many test aficionados would love for me to split out. An integration test is the same to me as an end-to-end test, is the same to me as a functional test. I'm going to use these terms interchangeably for the purposes of this talk. Please don't be mad at me, test aficionados who insist on separating these into different buckets. Okay, continuous deployment ingredients. I'm going to walk you through the list of ingredients that you need to have a successful continuous deployment pipeline. And then after I show you, so just like a recipe, I'm going to show you the list of ingredients here on this slide. And then on the next few slides, I'm going to show you how to put them together. So this, in my mind, is the full list of ingredients that you need to do what I would call full CD. You can, of course, do a subset of these and call it partial CD, but this is what's needed for a full CD. The first one is code review. You need peers reviewing your code. Unless you're a team of one, in which case, just ship it. Number two, you need self-contained build artifacts. This means that we do not run npm install or pip install or gem install on our production hosts. All of that has to be done at build time so that the artifact we're deploying already has everything that it needs in order to run. Number three, a central build system. We want repeatable, consistent builds that don't rely on some developer's laptop. And yes, you need this even if you have a scripting language that doesn't necessarily need to be built or compiled. You need unit tests. You need a code coverage check. You need a code review checker. So I mentioned earlier that you need code review, but you also need automation to verify that code is getting reviewed and not slipping through without a second pair of eyes on it. Static analysis. This is things like linters, bug finders, security check. There was, at Amazon, we wrote a lot of Java code, and we had an older tool called FindBugs that did a great job of finding common Java mistakes before they went out to production. We had security analysis tools that would look for common security vulnerabilities, such as, we got caught with a few of these occasionally where it was like, oh, you've opened this file, but you haven't closed it, and it could lead to an attacker having access to it after they shouldn't. Things like that. You need test environments. And I say this in the plural because I think most teams need more than one test environment. And I'll explain why later on. You need integration tests. Unit tests are not sufficient to fully exercise the full stack of software that you want to deploy. Load tests, alarms. This includes operational alarms like CPU usage, memory usage, disk usage, response times, things of that nature. And business alarms. Like if you're building a system, you should have alarms on the metrics that your business cares about. You should have the ability to do a gradual production deployment. So in other words, you don't just do a big bang where all the code goes to all the hosts in your fleet simultaneously. And you need bake time, which is a concept that allows your deployment to continue monitoring the situation after code goes to production and is fully deployed on production in case it takes some time for issues to crop up so that it can automatically roll back. And of course, 100% availability is required during deployment. No downtime during deployment. Time windows. So every team, I think, needs a time window where they can say, yes, a code deployment is allowed during this time window and not outside of it. For example, my teams at Amazon loved to set up a business hours time window where code would only deploy to production when we knew there were going to be engineers on the scene in case something went wrong and it did need manual attention. So we had, if someone happened to ship some code at night, it would not trigger a deployment. It would sit there and wait until the morning before it would actually go to production. And dial up and feature gates. So this is the idea that you can ship code to production with features that are hidden and unavailable to users unless they are turned on dynamically. Dial up is the idea that you can make features gradually available to more and more users over time. A feature gate is the idea that you can flip a feature on and off And you can combine these to have some really interesting features of managing features. All right, that's the set of ingredients. Now let's talk about a few concepts before I show you how to put all of those ingredients together. First of all, continuous deployment is a sequential process. Every code change flows through each stage in order. Each stage is designed to give us progressively more confidence, from unit tests all the way to right before you deploy to production. The final stage is the production deploy, and if any stage fails, the code change stops until the next change comes through and replaces it. One code change exists at any given time at any given stage. So we are not talking about like a branching parallel set of changes that are going out. We like to keep things nice and linear, so that, for example, if you have a staging environment, which is one of the stages of your CD pipeline, there can only be one set of code on that environment at any given time. Now, having said that, you can have multiple code changes flowing through the pipeline, just like I could put, multiple tennis balls into the sewer and send them down the drain. But they could be at different stages at the same time, never at the same stage at the same time. So here's what this looks like. Let's say I have a pipeline. Again, we're very abstract here, and I'm going to get more concrete in a minute. But let's say we have a 3-stage pipeline: stage 1, stage 2, and stage 3. And I've got a code change. It progresses through to stage 1. Then it progresses through to stage 2, and then it progresses to stage 3. But while it's on stage 3, a second code change has come through and is sitting on stage 1. Totally fine, not a problem. Pipeline should support that. Now let's say that stage 3 is the final stage for this, so that's like your production deployment. And code change B is sitting on stage 1, and it advances to stage 2. Meanwhile, code change A is still sitting here on stage 3. And you could imagine what's going to happen next when stage 2 is done with its work and the code change has successfully propagated, or maybe it hasn't propagated at all. Either one, and we'll talk about both those scenarios. But let's say that it does go ahead and propagate, and now it replaces stage 3 it replaces code change A in stage 3. So now code change B is sitting there in stage 3. Let's consider another scenario where code change C comes along, goes to stage 2, and for some reason it fails. That change will now stop in the pipeline. It will not progress. Stage 3 will remain unchanged. So there's like a hard wall here that it will not pass through. And it'll just sit there unless I manually force it to progress. All right, so what happens if code change D comes in? Well, just like before, it can replace code change C on stage 2. And if that succeeds, then it will replace code change B on stage 3. So that is just what I mean when I say sequential flow, and when I say that any given stage can have one code change running on it at the same time. Now, code changes are, of course, cumulative. When I make a change in Git, for example, on a branch, I am not just completely replacing that branch with a new thing. I am instead just adding a delta, like adding some lines, changing some lines, removing some lines of code. And all of those cumulative changes come along with code change D. So it's quite possible that code change D, in this case, actually included some of the changes that code change C introduced, and maybe some fixes to the bugs that code change C had along with it. All right, getting more concrete. Now we're going to move into some actual examples of specific pipeline setups that I have seen at Amazon and elsewhere, and I'm just going to walk you through how they work. So let's start. Here we go. A lot on the slide. We're going to go left to right and walk through this. So starting over here, a developer writes code and tests that code locally. All right. When they're ready to merge that code, the first thing they do is a code review, where their peers will look it over, and if everything looks good, then they will sign off and the developer will merge. This merge is what triggers a deployment pipeline to begin actually executing that change. Now, remember what I said earlier, changes are sequential and there can only be one thing happening at a time. Your build might be an exception to that rule. You could certainly have multiple builds going on at the same moment, and that's actually pretty common. But it won't be true for the rest of the pipeline. What happens in the build stage? So the build stage is intended to compile your code if that's needed. Maybe it's building a Docker container. But before it can do that, after it does that and says it's good to go, it first needs to run a whole bunch of tests, unit tests, including a code coverage check. I've seen teams set up rules where they say, for example, you have like a minimum, say 80%, some random, not random, but they pick a number that works for them and they set that threshold. Or they say the only rule is that the code coverage cannot go down with any new code change. We run static analysis like I described before. And if all of those pass, we publish this build artifact to our artifact repository. It is this repository that houses the canonical versions of our software that we want to be deployed. These are the self-contained artifacts that we will run in production. It's very, very important that it has all the dependencies that are needed as much as possible, so that when you deploy this out to your fleet of hosts, every host in the fleet is running the same exact software. Now, just a really quick note here. I am focusing a lot on like back-end web or front-end web service technology here. I'm not really talking too much about mobile devices, device firmware, and other things like that. I do have some notes on that at the end, but think when I say fleet, I'm talking about like a web service. Okay, so artifact repository houses all of our artifacts. The next step is to deploy that artifact to a test environment. A test environment is a set of hosts that are running your code. They go there, and then we have integration tests that run as a client against that environment. Now, these could be like back-end API tests that are headless. They could be front-end automation tests that exercise the application with simulated clicks in like a Selenium WebDriver or Cypress or something like that. And if these pass, then we advance to the next stage. If they fail, then we stop right here and we do not advance. So then I'm just going to continue here. So these 3 lines indicate continuing. Oh, but before we go on to that, let me just go back over here and say, this is an area that I think most teams really struggle with. When I have an upstream dependency, like a Node module or a Ruby gem or a Java package, how do I make sure that I get those on a regular basis? Well, a well-designed continuous deployment pipeline should take that into account and should have a regular schedule where it ingests changes from upstream dependencies. Maybe you do these once a week, maybe once a month, on a schedule that works for you. But the point is that these changes come in and run through the pipeline the exact same way that any of your team's code changes run through the pipeline. So an upstream dependency change can trigger a build just like your code can trigger a build. And if your pipeline is robust and your tests are complete, then there's really no reason not to trust those changes just as much as your own. Okay, moving on now. So after we've passed all of our tests in the staging environment, we now can move, or sorry, I call this test environment. We can now move on to our next pre-production environment. And I'm just calling it pre-prod here because I've seen teams do so many different configurations for their pre-production test environments. At Amazon, we had 4 different pre-production test environments that happened sequentially. And I'll tell you a little bit about those at the end. But in this example, I'm just showing 2. The difference, though, between the first environment and the second environment is that the second environment, we are more confident in that it is functionally correct, that the code change that lands on this environment has already passed all of our integration tests, which means it is a better candidate to run our load tests on. There's no use in running load tests on code that is functionally incorrect. So we run integration tests as a smoke test because why not? You don't have to do this. But we run load tests here to validate that this code is not going to introduce a performance regression. And you can see here I've put my time window check in. Again, the time window is how we ensure that code only goes to production during the times that we care about, because when code goes to production, that's when you're more likely to have an issue. And when you're more likely to have an issue, it's best to do those things while you have people on the clock instead of like a Sunday afternoon when people are trying to be home. So then we go to our production deployment, and this is where there are just a lot of options. So I wanted to explore 3 different ways to do the production deployment part of this, and I'll cover each of those next. So what is in here? That's where we're going. We're going to zoom into this box. And so the next few slides I'm going to show you are going to be inside this box. So like cognitively put yourself in that mindset as we go into this box. Think about all the stuff that's happened before we got here. Unit tests are done. Code coverage check is done. Static analysis is done. Security checks are done. Integration checks are done. Load tests are done. Code review was done, et cetera, et cetera. All that stuff is done. Now it's just a matter of putting this code into production. So in the production deployment stage, there are some requirements that differ from some of our other stages. First of all, we want to gradually increase the blast radius. We don't want to just dump all this code directly into production right at once. We need success metrics, so we know if the system is actually working the way that it's supposed to work. 100% availability. This is my third time saying that. No downtime is allowed in production, even when your infrastructure fails. And this is very important because what if you're running in AWS, there's 3 availability zones, you're doing a deployment, and one of the availability zones goes down. What happens to your capacity? Are you able to actually fully service your customer needs when you've lost an AZ and you're in the middle of a deployment? Some of your compute resources may also need to go down while you're updating to the newest version of code, depending on your strategy, which I'll go over that. So how do we accomplish this? Well, we have 3 options that I want to go through. First, before we go into that, I want to talk about alarming. There should be alarms always set up to monitor your code. How do you know when your production hosts are not working properly? And there are kind of a bare minimum set of alarms that I think every team should have as part of their regular ongoing alarming strategy, but also that their continuous deployment system connects to. First one, if you're running a web service, you should have HTTP status code alarms set up. If you start to see a whole bunch of 500 series alarms, that might mean that something is wrong with your system. Exceptions in logs. If you have a base rate of exceptions that show up in logs or uncaught errors, and you see a deviation from that base rate during a deployment, you need to know about it. Latency. Is your application getting slower when you deployed it? If it is, you might want to roll that deployment back and figure out what made it slow. Error rates, memory usage, CPU usage, and of course, business metrics. All right. And then real quick, before I get into the 3 options, a word on bake time. I mentioned that we need alarms while our code is deploying, but also after our code is deployed, we need to continue monitoring it for a little while because some issues are latent. They take time to appear. Maybe there's a bug in a low volume API that doesn't get called enough, as much as your top APIs. So you need some time to keep an eye on all of the different parts of your code, so that you can so that your deployment can roll back. The question is how long? And really, that is the wrong question. You should not be, even though I use the word bake time, you should not be thinking of baking in terms of time. You should be thinking of it in terms of metrics, such as number of requests. Okay. And I hope it's clear why. And let me just explain why real quick, which is that let's say you're deploying at a time of day when you have lower traffic. Well, 30 minutes during a time of day with low traffic could be a very different, it could give you a very much lower confidence than 30 minutes during a high volume of traffic. Like let's say you've decided that you need 1,000 requests to your web service so that you feel confident that it's working correctly. Well, during a low traffic time, 30 minutes might not get you that 1,000, but during high traffic, 3 seconds might get you 1,000. So it's important that you count the things that you are testing rather than the amount of time that has passed. Or in other words, as they say, it's the miles, not the years. Okay, now, 3 options for the production deployment strategy that I'm going to describe. One of these options is terrible, and I'm just going to start with that one. So one way is all the pre-production steps happen, and then you deploy to all of your production hosts simultaneously. You have no automated alarming, and then who knows what happens, and finally, profit. Obviously, we're not going to do this, but I just wanted to throw it out there because this is something that is intolerable. Now, if you're a startup that's running in, right out of the gates, and you don't have any customers yet, maybe this is an option for you, but this is not what I'm here to talk about. Now let's talk about option 1. Excuse me. Don, could you hand me a cup of water, please? Just kidding. Okay. Option 1 is this thing called one-box deployment. So some assumptions with this. Number 1, you have a fleet of hosts. So multiple hosts running your software, and you could have one host safely run a newer version of the code than all of the other hosts for some period of time. Okay, it's called one box because what this does is we take the new code and we deploy it to one production host only. Then we monitor the alarms from that host only, and this is our bake time. So what this requires you to do is to designate which host in your fleet is the special one box. And it's not that host is magical, it's just that it's the one. And of course, it can be replaced, but it is the one. And when it publishes alarms, it publishes them with extra metadata to say, hey, this alarm came from the one box host. That way you can set up alarms that connect to those metrics And if they go bad during the deployment, you know to roll back, or your system automatically knows to roll back this one host instead of the remaining hosts in the system. If you pass the bake time successfully with the alarms, then we move on to deploying to the remaining fleet. And here I've split this into two parts because they run in parallel, and that's because our alarms are always running. They're running whether or not a deployment is happening. But during this period of time, the deployment pipeline system will be monitoring those alarms to see if the deployment changes some of them from green to red. And I picked here just 33%, just to throw it out. This number, the whole idea behind this number is that you are actually taking hosts out of service from your production fleet. And maybe you only have 3 hosts. This still applies, but you're taking them out one at a time, changing the code on those hosts, and then putting them back into service, and then moving on to the next batch of a third. But you've capped it so that it only happens to 33% at a time. Now, deployment pipelines will have this as a strategy, and you can configure what the size is. Maybe for your team, it's only 5%, maybe it's 50%, but it depends on your tolerance for availability of your underlying infrastructure. At Amazon, our policy was we want all of our hosts to be spanned across 3 availability zones in AWS. And we take we always want there to be enough hosts available to serve peak traffic, even if we lose an availability zone, which would be about a third of the hosts, and a deployment is happening at the same time. So that means we're over provisioned, but it also means that we have a lot of safety when it comes to deployment. Then after all of 100% of the hosts are running the new code, we would continue to monitor alarms on all the hosts for a pre-configured period of counts. Again, I call it bake time, but it's not really time. It's a count. Okay, that's option 1. Now remember, this is a little different from what some of you may be running your code on right now. Like you're like, well, I use Lambda. I don't even have the concept of a host. Or I use ECS. I don't have the concept of a host. Well, that's why option 2 is for you. But we'll get to option 2 in just a minute. Before we do that, I want to go over the pros and cons of option 1. So pros, this works really well for large fleets. And the reason it works well for large fleets is because if you have 1,000 hosts in your fleet, which would be a really, really big fleet of hosts, one host represents 0.1% of your capacity, which means that only 0.1% of all traffic could be subject to bad code, which is great because you can monitor. You can run this code in production and get a really good read on whether this new code is working, while only jeopardizing 0.1% of all your traffic. This is cheaper than other techniques too, like a blue-green deployment strategy, which we'll talk about next, especially if you are using reserved capacity. So reserved capacity is an AWS term, which means that you can pre-buy EC2 capacity, but you have to agree to use it for some period of time, like 1 year or 2 years. Or some number of months. And this is great because I actually did a bunch of analysis, and it turns out that that even when we at Amazon used, like if we could shut down our hosts during low traffic time or surge hosts up during deployments, it was actually cheaper just to buy enough reserved instances to serve at what would be the peak traffic of any given day, even if that only lasted for a couple of hours. It was cheaper to just buy reserved instances to meet that, to have enough capacity to meet peak traffic times than it was to buy on-demand instances and auto scale up and down throughout the day. So that was an interesting finding. So if that's you, this might be the right option for you. And you don't really need a super smart load balancer that does a lot of work for you. All you need is a load balancer that can pull hosts out of traffic or out of service and put them back into service. Very, very simple. Every load balancer on Earth is able to do this. Okay, but there are some cons as well. For small fleets, one host is actually a really big portion of your traffic. So if you only have 3 hosts and you pull one of them out as the one box host, you've now potentially impacted a third of all your traffic. That's a far cry from 0.1%. And you can also miss errors if you're in a low traffic moment and one host is a small percentage of your fleet. It's really easy to miss errors because you just don't have enough traffic going to that host. All right, and rollbacks are slow because you have to actually go back and do a redeployment on the hosts that have already been moved over to the new code. Option 2. This one is a more modern take on safe deployments to production. And this is what my team is doing now. It is a little bit more expensive. There are some pros and cons we'll talk about, but it's really, really useful. But there are some assumptions. First of all, you need a pretty smart load balancer that understands the concept of blue and green, because it's going to be routing traffic to new capacity that got stood up and is very specially designated as temporary and new. This also assumes that you have on-demand capacity. What I mean by that is that you have the ability to spin up new hosts or new endpoints that can serve traffic on demand at a moment's notice without having to go get approvals and sign large contracts and things like that. It also means that you can bring up a clone, a complete replica of your production fleet, not the database, data stores, or other persistent state, just the runtime systems, but that you can have a full copy, 100% replication of your fleet running at the same time as your main fleet. So let's go into this. What does this look like? So first of all the pre-production steps are outside of this. And what this does is it stands up a duplicate production fleet. So let's say you've got like 10 instances of Docker containers running on like an ECS Fargate configuration. This would set up 10 more. So during your deployment, you would have double the number of Docker containers running, and gets it ready. Now, it doesn't start sending traffic to those new Docker containers or Lambdas or whatever they are. It doesn't send any traffic to them yet. It's just preparing them to start receiving traffic. And of course, we have alarms being monitored on this new fleet. So we know the difference between an alarm that originated from the new fleet and an alarm that originated from the old fleet. So step one is we pick a percentage. And I've just said 10% here, but maybe that's 1%, maybe that's 1/10 of 1%. And for every HTTP request that comes into our app or into our load balancer, we randomly have the load balancer send 10% of those requests to the new fleet. And then we wait for some period of time. This is bake time now. So we wait, based on the number of requests or by, some metric, some threshold you want to cross, or by a configurable amount of time. And at any point, if the alarms go into a red state while this is happening, then the load balancer immediately stops sending traffic to the new fleet and restores all traffic to the old fleet. This is really, really fast. So you can respond to an alarm in a matter of seconds instead of waiting whatever the deploy time is for your software to come up on hosts like we saw in the previous option. And then you rinse and repeat. You increase that threshold from 10% to 50%, and maybe you go to 100%. You can have as many steps as you want here, and I think every team can make that choice. But the key is that you're building confidence over time to where you feel comfortable running the whole fleet, sending all traffic to the new fleet. And then, of course, you have monitors you have bake time where we keep monitoring the alarms on the new fleet. After we get confidence and all that, then we can shut down the old fleet, because with all of these hosted, serverless technologies, time is money. And so you pay for these things on demand as you use them by the minute or whatever it is. And so we wanted to shut down the old one so that we're not running this thing all the time. Okay, there are pros and cons to this approach as well. One of the pros, like I mentioned before, very fast rollback. Within seconds of an alarm, you can have the state of your software reverted back to the previous state. You have very fine-grained control over the rate of cutover, much more fine-grained control than the one-box approach, because the one-box approach depends on how many hosts you have in your fleet. Like I said before, if you only have 3 hosts, then one box is 33% of your fleet, and you don't have any more fine-grained control over that. But this is doing sampling at the request level. So as HTTP requests come into your load balancer, some percentage of them are being sent over to the new fleet, and it doesn't matter how many instances you have. It could just be one Docker container for all we care. It's just going to be getting 10% of the traffic. There are cons too. This is more expensive to operate. You cannot use reserved capacity with this approach because you need access to on-demand capacity to bring up for deployments. And during your deployments, you are paying double for your compute capacity. And it requires a load balancer that's capable of doing this. So at AWS, for example, if you are using ECS, Fargate, something like that, or Lambda, you have access to the application load balancer, and you can use code pipeline and code deploy and it is all integrated to control that load balancer so that it does the dial up the way that you've specified and does the rollbacks based on the alarms you've specified. But if you're rolling this yourself and you're just like deploying HA proxy or Nginx or something as your load balancer, it's probably a lot harder to orchestrate all of this stuff. Okay, so those are the three options that I wanted to talk to you about. I've got a bunch more material that's ancillary to this whole thing. And I want to go into each of those things now. So we're going to talk about things like multi-region and other stuff like that. But these three options that I just described, these are pretty much the archetypal patterns that I've seen for all the teams that I have observed that have done continuous deployment. Now, are there other ways to do it? Oh, yeah, there probably are. I just haven't had firsthand experience to them. And what I'm showing you right now are things that I have seen teams do, and I know they work across many, many teams. So just wanted you to see all of that. Let's now leave this topic and go into kind of some more meta topics about CD. First of all, what do you do if you have multiple regions that you have to support? Like, let's say you run your software in the US, and also you have a replica stack in Europe with its own databases and its own set of users, and you've got one in Asia as well. How do you manage the rollout of these things? Well, I can tell you how I've seen it done successfully before, which is that you sequence the regional rollouts. You do not just blast all the code out to all regions at the same time, because doing so gives you the maximum blast radius. You might even say it's a global blast radius doing that. Instead, you can strategically pick the order of how you roll these things out. And again, we want to do this to minimize blast radius and maximize our confidence in the smallest amount of time. One way to do that is to start with the lowest traffic region. Deploy there first, then do bake time. Then deploy to the highest traffic region. Then do bake time. Now, at this point, you've sent your code into two of your strangest regions. You have the low traffic and the high traffic region, which I only picked them because these are probably your outliers. And if let's say you have 6 regions where all of your code is deployed and your services all run there, it is likely that all those other regions inside of the lowest and highest traffic regions are probably a lot like, are probably less complex and have fewer edge cases than the high traffic and low traffic regions. So by doing those two first, you increase confidence that all the rest will come out more smoothly without any issues. What about databases? So one of the questions I get is, I have database triggers and I have stored procedures. What do I do about these things? And generally, these all fall in the category of database migrations. And there really are a few different ways to do this with continuous deployment. You do have to solve the problem, though, before you can go to CD. So first of all, I think there are basically 3 ways that this can be done, and I've seen it done successfully all 3 ways. Number one, you can do this in the same deployment pipeline as your code in a step that runs before the code deploys to each stage. Okay, this has pros and cons. One of the pros is that it's easy to ensure that the migrations run before the new code is out on production. The con, there's 2 cons. Number one is that it creates coupling between your code deployment and database migrations. So if your database migration fails, then you must not proceed with the code deployment. Usually, of course, by policy, you can overcome that, but usually that's how it works. Now, this might be a good thing if you want to force your developers through this forcing function to ensure that they always that their code will never run on production unless the migration has successfully run before. And it might, of course, a failure in your database migration can block your code deployment, and that is maybe a good thing, maybe a bad thing. The second option is to run your database migrations in a totally separate deployment pipeline that is in no way coupled to your code deployment pipeline. The pro of this is that it is totally decoupled from your code deployments, which means you have maximum flexibility to run, to put out new code and put out database migrations whenever you want. This forces you to make your code able to run with both old and new database state, since it won't necessarily be, database will not necessarily be up to date when your code runs. So that's a good thing and a bad thing. Another con is that it can be more code for you to write, because your code will end up being peppered with dual reads and dual writes, where you have to take into account the fact that the database could be in an unpredictable state at any time that your code runs. And I say that as a con for this second option, but really option 1 also has this same con. I mean, some of you are probably thinking, yeah, why is that any different? Well, the fact is, you might choose to skip a database migration, and your code has to deal with that. So a well-written code really should take into account all possible database states, whether it's new fields, whether it's some stored procedure that exists or doesn't exist, and so on. Okay, option 3 finally is manually, and I actually, most of the teams that I worked on at Amazon just did this. And some of you are nodding your heads and saying, yeah, this is how I do my database migrations. And I say, okay, you're probably using Mongo or DynamoDB or some other NoSQL database. That's one of the pros, is that you're probably using a schemaless database if you're really in favor of doing manual database migrations or these kinds of things. And the cons are that you're probably using a schemaless database like Mongo or DynamoDB. Let's talk now about something I referred to earlier, which is separating deployment and launch. I talked about feature gates and dial-up, and the idea here is that when you're writing code to build a new feature that's not actually ready for users to use yet, you still want to be able to put that code into production so that you can test it. Maybe you want to do a beta where you show it to users before it's ready for everyone. Maybe your testing team wants to test it in production before they make it live for everybody. You need a feature gate system. And there's probably a whole talk I could give on feature gates alone, but suffice it to say that there are essentially 2 things you need to be aware of. One is the idea that you need to gate your code. The other one is that you can dial up your code gradually. This tends to work if you have a lot of users, whereas if you are like an enterprise SaaS company and you've got like 100 customers, it's really hard to do a dial up with these people because a lot of times, or with these kinds of customers, because a lot of times they have change management systems and they need to know exactly when they're going to get new features. Excuse me. At Amazon, of course, we had a really robust dial-up system that would allow us to randomly target a percentage of users with some really clever infrastructure involving Bloom filters to make sure that we could roll out code to users as we wanted. And we used this dial-up feature to our advantage because we treated it kind of like continuous deployment. You dial up a new feature, you observe that feature in production, you monitor all of your alarms, and maybe you start at 1%, and if you see everything looks good, you keep going. But if you see things look bad, you roll it back to 0. Okay. Now, is CD appropriate for everything? And the answer, I'm pretty sure, is no. And let me just go through the areas where I saw it used and the areas where I saw it not used. So number 1, code deployments, obviously, deploying code. I also saw it used for deploying machine learning models. So like, let's say you want to pump out a new neural network or a new revision of a neural network. CD is great for this. In fact, one of my first teams was responsible for the model deployment for some of the machine learning models that powered Alexa. And we had parallel pipelines for code and models, and they could run independently of each other, although some coordination was needed. Operating system patching. So Amazon uses pipelines for everything. So various pipelines. You need to patch your operating system, you need a pipeline for that. You want to deploy models, you need a pipeline for that. You want to deploy code, you need a pipeline for that. Even infrastructure changes like CloudFormation were managed with a continuous deployment pipeline system. So you want to change a VPC configuration, you want to change a load balancer setting, you need a pipeline for that. And it was actually a really, really good idea. Configuration changes also went through similar procedures. Some teams would have dynamic configs that would roll out with a pipeline, with a deployment pipeline, the same way that code deploys. Internal tooling even, including the very deployment tools that were deploying themselves using the deployment pipeline systems. They deployed themselves using their own tools, which was pretty darn cool. Now, here's a few places where I saw CD not used. At Amazon and elsewhere, and I've actually done an informal Twitter poll on this topic too, and I think this is pretty much a general statement, but CD is not great for some things, like mobile apps. Mobile apps, by necessity, have an App Store approval step. The Alexa smartphone app was a good example of this. It is very much a waterfall process. You build, then ship. You just can't ship a new version of your mobile app every 15 minutes. Embedded device code like firmware and things like that run on Echo devices or other things. It's very, very hard to do CD on these things. You can take it to a point and you can have continuous integration, but continuous deployment, when over-the-air updates are involved, it's just not really appropriate. Front-end UI. like maybe an Apple TV app, for example. Probably not the best choice for CD. Now, continuous integration, yes, great idea, but not necessarily full continuous deployment. All right, how do you get your teams to adopt? CD does not have to be all or nothing. You can do partial CD with manual approval steps, and I'll show you some pictures of this, where you have like a stage that requires a button to be clicked. And now I'm going to show you a few examples of that. So here's one of my current team's pipelines. It has 10 stages, and it is partial CD. So this comes from AWS's code pipeline tool. You can see here the very first stage is our source stage, where we pick up triggers from a GitHub repo that when something is merged. The next stage is the build step, which in our case creates and publishes a Docker container to Elastic Container Registry. The third step is our database migration for our first test environment that runs any migrations that are in the system, that are included in this batch of code. And then we deploy to a staging server. Then we have a manual approval to go to our next environment, which we call release. You can see here we have two people that have to click a button. We have an engineering lead and QA who have to sign off before this will go to our next environment. This is a partial continuous deployment system. This is not full CD yet. We're working on it. And then you can see if that gets approved, and you can see that happened 5 days ago, which is kind of interesting. Then we will run the migrations on that system, on that environment. Then we will deploy to that environment. And then again, we have another approval before we go to production. And you can see here, we actually have a change pending. We're waiting for the engineering lead to sign off, but the QA team signed off 5 days ago. So that kind of gives you a sense for the longevity. This would never happen in a full CD system where you have like 5 days before it even starts to go to production. But in partial CD, this happens all the time. So that is, here we go. So this is the final stage of the pipeline, where we have a production database migrations, and then production deployment, which we're using an Amazon ECS blue-green technique for that, which I said before, I just absolutely love this. It's really, really great. So here's another example. This is from a previous team. This one has 8 stages, and it is full CD. This next slide is going to be very, very busy. So brace yourself for impact. I've covered up a lot of the stuff that reveals anything about the software that's actually being shown here, but it'll tell you a concept here. So over here on the far left, we have a list of all the different Git repositories that are being monitored for changes. This is our build stage. You can see we have code coverage here running. We have a code review verification to confirm that any commit that gets to this stage only proceeds if it has had a positive sign-off from another engineer. I'm not going to tell you what's in this box. This box is our first testing environment. You can see we deploy to 3 different test environments here, and then we have multiple tests that run. Our second test environment, there's actually 3 of them inside there too, with 3 different sets of tests that run against those environments. And then our third and final test environment, which again, there's 3 sub-environments there, and a whole bunch of different tests that run on those. And then finally, we have our multi-region deployment divided into waves. So we have wave 1. This is actually the wave 1 box region. It's the first region 1 box deployment. So this is just one host of a fleet of about a dozen or so hosts. And we run a bunch of tests, including we have our bake time right here that's just monitoring for a certain amount of time. This one took an hour, you can see, before we got all of the metrics we needed. After the 1 box passes, then we hop over to the full fleet for that same region. And again, remember how I said low traffic region, high traffic region? This is the low traffic region. I think this is the high traffic region. I think we did it a little differently for this one. We only had 3 regions. Then lastly, we go off to the 1 box for wave 2, which is actually 2 different regions that have a 1 box host in each region, each with their own bake time, each with their own tests. And then after all of those pass, then we go in parallel to the final 2 regions, full fleets. You can actually see this documented, not this exact example, but this identical pattern documented here on this website. It's in the AWS Builders Library, which if you haven't read or looked into the AWS Builders Library, it's really, really good. There's a lot of excellent written material there about how Amazon operates its teams software internally. Fantastic. This one is called Automating Safe Hands-Off Deployments. Very, very much recommended. Okay, that is it. That was all of my material. I know that was just a whirlwind, really, really fast. I think I took a few minutes more than 45 minutes, but that's all I brought for you today. And I would love to just take questions.
Very good. All right. So we had a couple questions in our Ask a Question dialogue that is still open. Anyone please add your questions there at the bottom in Crowdcast. So the first person asked, is there a recommended book that does a good job helping a newbie get up to speed on CD? So
Great.
I think you had that link there in the slide there. So is there any other answers?
Yeah, so I mentioned before that I read the Continuous Delivery book by Jez Humble. I think that one's probably not a great resource for a newbie. That's the only book on the topic I've read. So that's all I've got. I do, though, like you said, Don, I do recommend that link that I shared in my previous slide here, the AWS Builders Library, Automating Safe Hands-Off Deployments. That's a great place to start for a newbie. And then I noticed someone in the comments here answered and just said, look, build a pipeline with the fundamentals. Could not agree more. I think if you take the material in these slides and then just start building, you'll probably get all the experience right out the gate.
Perfect. All right. And so someone else asked about the slides. And so what we'll do is we'll put a link in the meetup notes and we'll put it in the comments here as well. So we'll make sure everyone has access to the slides. If you registered on Meetup, you'll see them there, and on Crowdcast, we'll figure out a way to add them here. Okay, more questions coming in. Great. Let's do. Can you share some context on why a deploy could take multiple days?
Yeah, great question. So in AWS, like if you are an AWS team, you actually have to run your software in like dozens of regions, and each of these regions has its own infrastructure. So I've seen teams that take days and days and days to get code changes out to all, I don't even know how many regions there are right now, 30, 40, 50. It can take a lot of days to get those all out. And that's actually by design because sometimes code changes introduce problems and it takes a few days before people realize that they're problems. And so they want to keep the blast radius small by deploying to a few regions and let that bake for a while.
Very good. Okay, so we had another question. Could you give more examples of where CD is not a good idea, such as the Apple TV UI and why that isn't a good idea?
Yeah, so I'll broaden this to say that most front-end web applications are also in this category, in my opinion. And the reason is it's very hard to get full confidence that your code is not introducing a bug without a manual tester going in and clicking on things and running a regression test. I've never yet seen a full automation test suite that can fully validate everything enough to where I would say, let's make it CD. Now, if any company on earth was going to say that they have done that and that it works, it's Don's employer, Lucid. This team has, I think, done a fantastic job with that. So they will probably know something, but everyone I've talked to who has a front-end app that's any level of complexity says they can't do it. In the case of Apple TV and mobile apps in general, it's because you literally can't. Apple will reject your apps if you start sending them apps every single day for what do they call it? Through the app submission process.
Very good. And so, you mentioned Lucid there. Basically, Lucid's solution is a massive end-to-end test suite. For existing features, it's just, it's basically 1,000 end-to-end tests that run on every merge. And then, there is manual validation for all new features, and then new tests get added with new features as well. So that's the answer there. Nothing fancy. Okay. Here we go. Was Kubernetes used for CD at Amazon?
So I saw hundreds of teams at Amazon, and I never saw one using Kubernetes.
All right, fair enough. Have you ever seen a CD system spin out of control so starts behaving incorrectly, or is it just very unlikely with a good quality CD system?
I have seen. I think the short answer is no. I've never seen one go out of control, like start deploying random stuff to production and just like, like code, deploy. Never saw that. Certainly not out of the realm of possibility. The worst that I've seen is where the deployment system itself has a bug and it starts deploying subtly wrong versions of your code. Like maybe it grabs an artifact that's a few versions older than you expected, something like that. But I've never seen it go out of control where it's just like, deploy every commit, like every commit in your Git history.
Got it. Okay. Let's see. Next question. What ideas have you seen for application configuration for running apps in different environments?
This is a great question. What I have seen, I've seen a couple of different things, but the most common pattern I've seen is where you actually build your configuration, your app configuration. So actually, let me back up and say what I'm talking about. App configuration, things like this. I've got a test environment and a production environment. And my test environment uses a database. That database has a password. And my production environment uses a database, and that database has a password. Passwords are probably not a great example because you don't want to store them as like clear text as a configuration file with your app. But think of another example. Like we have like a New Relic key or an endpoint that we use in this environment versus that environment. Or an even better example would be like my application runs in Europe and the US, and in Europe it has like a different subdomain, and in the US it has a different subdomain, right? So these are all configuration. So when I say application configuration, this is what I'm talking about, and I hope that's what David, the question asker, is also talking about. What I have seen works really well is a couple of different approaches. One is a file-based approach where the files themselves are checked in to the application code right alongside all the code, and those files get bundled into the artifact that gets deployed. And each artifact contains all the configuration for each artifact contains all the configuration for all the environments, all the test environments, all the production environments. Now, this is a good reason why it's important not to put credentials in here. There's other techniques for storing credentials, but things like what's my subdomain? You have like a map, like a dictionary that says, okay, what's your environment name and what region do you run in? Like I'm a test environment and I run in Europe. It's like, okay, well then your subdomain is X. And it's like, okay, I'm a production environment and I run in North America. Okay, your subdomain is Y. And Amazon has a system called the Brazil configuration file system, where you can specify all of these things in a flat file, including like wildcards. So you can say like all test environments in any region have this configuration, or all production environments in Europe have this configuration. And it's pretty good. And I think it works pretty well. And it's one of the advantages to bundling all of your configuration into each artifact is it makes rollback actually work really effectively, because you know that the code in the artifact has been tested with the configuration in the artifact. So if you need to roll back to a previous artifact, like let's say it's a Docker container, you need to roll back to a previous version of the Docker container, you know that code has been certified to work with that configuration. And the alternative to this, so I've just described one way to do it, which is put all your config in files in your app's artifact. But another way to do that is to have like a parameter store, which AWS actually has a system called Parameter Store. It's publicly available, where you can just store configuration in a service that your application can query at runtime or at startup time. This has the advantage of making the parameter store or making the configuration easy to change, and it's dynamic. But it has the disadvantage that now it is essentially a schema and it's not bundled with your app. So if you want to roll back, you have to be confident that the code that you're rolling back to is compatible with the data that's in the parameter store right now. And it's possible that the code you want to roll back to was never tested against the data that's in the parameter store now. So that was kind of a long-winded answer, but those are the two approaches I've seen done effectively. One is you bundle all the configuration into the running application, into the artifact with the code. And the other one is you use like an external an external parameter store of some kind where you can store all that configuration for different environments.
Awesome. That was a lot of great information. Okay, so another question from David. Do you recommend storing compiled source code as well as the Docker container?
Storing compiled source code. Like as an artifact, I think maybe is what David is asking.
Yeah, probably.
The fact that it says compiled source code kind of confuses me. I feel like that might be maybe a typo. But I don't. I guess let me answer the best I can. I think your Docker container ought to be a standalone artifact. If you're trying to figure out what version of the code was used to build that Docker container, then I think for that, I would rely on my revision control system. And what we're doing at eVisit is we tag each Docker container with the Git commit of the Git. Sorry, let me say that the right way. We have a tag applied to each Docker container that tells us what Git commit it was built from. So if you ever want to get back to the code, you can do that with Git. Now, you just reminded me of something that's very, very important. Git is not a deployment tool. And I think using Git as a deployment tool in a continuous deployment environment is a recipe for problem. So what I mean by that is a lot of people, I'm looking at the Rails community and Capistrano and others, they use Git as a command on production hosts to choose the version of code that is now installed on that host. This is very challenging because, creates a lot of challenges because it's very hard to recreate the exact artifact that was tested. Whereas if you put everything into like a Docker container or some other binary that can be deployed onto your hosts, that what's been tested is A, it's what's running is what was tested, and B, it's the same on every single host. But if you're using Git as your deployment tool, you know for sure that you're bringing in source code, and that source code has dependencies. And where are you going to get those dependencies? Well, you're going to install them at runtime. Well, what version of those dependencies are you going to get? Are you going to get the exact same version that's running on all the other hosts on your system? You don't know, actually, and there's no guarantee unless you're very, very meticulous about pinning all the versions, or you have a very well-maintained lock file. But all it takes is one error and you end up with different versions. And the reason I know this is because while at a previous company, we had exactly this happen. And the way these kinds of things manifest is you have a customer calling up and saying, hey, sometimes I get an error, but not all the time. And they say that because maybe you've got 5 hosts and one of them is running a different version of some Python library and it's causing a bug. And 1 out of every 5 requests that run to your load balancer hit that server, and that server manifests the bug. So anyway, sorry, I kind of went on a little bit of a tangent there, but the bottom line is Git is not a deployment tool. And if you use it as a deployment tool, you're almost guaranteed to have problems like that.
Great. All right, so that's all the questions we have for now in the dialogue. But please chime in from the crowd here. Anyone else have new questions? I've got a few of my own that I wanted to ask here. So one thing that I personally am curious about is like test hygiene as you move forward. Let's say you're on continuous deployment and you're developing new features. What did you see? What practices were in place to make sure that the automation testing was kept up to standards to support CD going forward?
Yeah. So great question. Mostly this was done through unit testing all right. I'm going to speak from my experience here because I have pretty limited experience, and I'm not talking about front-end apps or mobile apps or device software when I say this. This is mostly back-end, and where I've seen it done effectively is by having lots and lots of high-quality unit tests. No new code goes into the system without a unit test. No bugs are fixed without a unit test, and you have to put in the work up front to get your unit tests up to good enough coverage that you're confident. And without it, it's absolutely a cornerstone. Without a good unit test coverage, your CD it'll eventually cause more pain than it'll resolve. So that's
is that verified through some sort of code coverage, monitoring?
Yeah, in fact, the first step in the build stage that in my previous teams was to verify that the new code coverage. So you got an incoming commit, right? New code change. It would run the unit test and then generate a code coverage number. And the first step was if this new number as a percentage is lower than the previous run's number, fail the build, right? And so we just block it. Now, does that mean you have to stop and you have to add unit tests? Well, not necessarily. You can override the failure and move on, but at least you have a mechanism to say you're going backwards, not forwards.
Gotcha. Very good.
I've seen that work pretty well.
Cool. Yeah, that's a cool technique. All right, so we've got a new question. Recommendations on password management.
Okay, so I am not an expert on the modern ecosystem for this, but within Amazon, my eyes were opened to password management. We did some really, or I didn't do this, but they have some really great tools there. that are totally separate from the configuration strategy that I mentioned before, where you can store credentials in an encrypted way, and then your application could request these credentials on startup, so they're never stored in persistent storage on disk on any host. They are just downloaded into memory, and they are only exist in memory. And so you can do access control on these credentials. And I think, if I'm not mistaken, I think AWS has a tool that I have not used for that, but it would absolutely be the first one that I would go look for to see. Oh yeah, AWS Secrets Manager. Yes. And you might think, oh my gosh, this is so simple, I should just build this. But I would advise you not to do that, because a proper credential store will do all kinds of valuable stuff for you. Like, for example, credential rotation. Like, let's say you've got a database with a password and you want that password to change periodically. Your credential store could be integrated with your database so that it will create a new password, leave the old one active for a little while, and then make sure all your hosts are now using the new password, and then deactivate the old password. And it has this nice like rotation. And we did this so much at Amazon that our AWS keys were actually rotated every single day. So you could never find a key that would last for more than 24 hours. That was awesome, like maximum security. I was super, super happy with it. So that's what I recommend, is get out there and see. I'm quite sure that something exists. 5 years ago, when I guess between 5 and 10 years ago, I was looking for this, and I never found one. But I'm quite sure that it must exist now, because AWS has it. And if AWS has it, that means that 3 startups built it first.
Nice. Okay, next question. What other variations of the blue-green strategy could you elaborate on?
Oh boy. I'm kind of drawing a blank on this one. The biggest one is how you do your dial-up to the new fleet. And if you go into AWS Code Deploy, which is one of their tools, you can then go and set up a deployment strategy, and they'll have all these options. In fact, I'll bet you if you just Google AWS Code Deploy blue-green strategy, you'll find all kinds of interesting documentation about what the different options are. Yeah, oh yeah, there's tons of stuff. Yeah, really, really good stuff there. So go Google that, and you'll find 10 times more information than I could tell you.
Very good. All right. Next question. What do you mean by revision management system?
Okay, I don't remember saying revision management system, but there's probably 2 things I could have meant by that. One is just version control, like Git. And another thing would be like your artifact revisions, so that the system knows what version of each artifact is supposed to be deployed at each environment. So AWS Code Deploy keeps track of this. So Code Deploy knows about your target environments where you're running things, and it keeps track of which version, for example, of a Docker container is supposed to be deployed at any given time. And so when you scale up your fleet, let's say you have 10 Docker instances running, at the moment, and you want to scale it up, it knows which version of Docker to put on the new instances. So like, let's say you go from 10 to 12, you got to stand up 2 new instances. Code Deploy does that all for you, and it'll put the right version on them. So those are the 2 things I might have meant by that, is revision control system, or like an artifact revision management system.
Very good. All right. So I wanted to switch gears and ask about your podcast. You host a podcast with a co-host. It's called Soft Skills Engineering, I believe. Is that correct?
Yep, that's it. That's right.
So if someone wanted to, get started with this, what's like a good episode that you think would be a good intro? Just the latest one, or is there a really, sparkling episode that you thought would be just, a great representation of what people can learn here?
Thank you so much, Don, for pitching the podcast.
Softball.
So yeah, it really set me up. So we have a podcast called Soft Skills Engineering. It is an advice show for software developers. So we have my co-host Jamison Dance and I. We take questions about non-technical topics. So things like, how do I deal with my boss who's driving me nuts, or I have a coworker who refuses to write unit tests. What do I do, et cetera, et cetera. And we just provide answers to those questions. And one thing you need to know about the show is that 80%, maybe more than 80% of what we say is just meant to be silly. And I just spend most of my time laughing, and Jamison spends most of his time saying smart things. So anyway, go check out the show if you're interested in that. there is an episode that I want to recommend. Let me see if I can dig this up for you. Oh man, sorry, I can't remember that. I'll find it here. There is an episode about somebody with really stinky feet.
Oh no.
Probably
Oh,
my
no.
favorite episode. Yes, episode 131, where someone says, "I sit at a desk with 3 people, and one of those people does a great job of personal hygiene. The other 2 not so much. I have dropped a couple of hints about it, etc., etc. Some days my stomach will churn because of the smells that waft over." Anyway, so the question is, what do we do? Oh yeah, one of them puts his feet right underneath my desk, and it creates an absolutely awful stench. What do I do? So that's episode 131. If you want to check that out, that's probably my favorite episode of all time.
Well, that's a cliffhanger as far as what your advice would be there. I'm curious myself. As a person who's been in an office where that was an issue, I am actually going to check that out. Yeah, unfortunately, I had to deal with that.
Thanks, Don. You probably did a better job of it than we recommended.
Well, yeah, yeah. We won't go into what my solution was. All right, so we're just about out of time, and so let's do the prize giveaways and go from there. So we've got let's see, 4 prizes. 2 JetBrains license, and then the Agile Learner subscription. And so I've got people randomly selected here. So if you would like this prize and want to accept it, please respond in the chat. So RJ smirks for a JetBrains license. Is this something that you can use? Are you here, RJ? Respond in the chat. Also, Scott Fesher, you're the other winner. Are you both you guys here? We'll go to alternates if we don't hear very soon. Yes, Scott, you win. Very good. Okay, so RJ, are you here? I don't see you responded yet. Okay, looks like RJ's not here. So let's go to Kent Bull. Kent, I think I saw you answering some questions. So this is some karma coming back to you. Regardless if you're here or not, Kent, you're going to win it. Because I liked how you were answering questions. Okay, so Agile Learner. Let's go with that winner is iHatch. iHatch, are you still here? We will look for his response. Yes, RJ is here. Very good. Okay, so RJ responded after let's see, did I give it to someone else? So I think I've overpromised here, but it's good. I didn't give away the last prize. So the last prize goes to, let's shift this to where I was going to give David, yes, I will give iHatch the next prize, which is the $25 gift certificate for tech. So you get that one. Okay, so that's it for prizes. Just a reminder, next month is NVIDIA coming to talk about their mixed reality, AR, VR solutions. And then July is Mark Richards. And that's it. This we will post the slides as a comment here in Crowdcast and also on Meetup. And then this recording will be available here on Crowdcast and also on the YouTube UJug channel. So that's it.